Good morning and welcome to this webinar on migrating applications to JDK 9. My name is Simon Ritter. I work as the Deputy CTO at Azul Systems. The idea of this presentation is to look at really what are the issues that might affect you in migrating applications to JDK 9. So we're not going to really talk about how you port applications. We're not talking so much about the way that you might change your code. What we're looking at is very specifically things that might affect your application when you start using JDK 9. It will become apparent what I mean as we go through. So the first thing obviously is just to talk a little bit about JDK 9. JDK 9 came out a couple of weeks ago. It was finally released as the general availability, and there are a lot of big and small changes. And so I've kind of used this slide from Oracle, which lists all of the changes that have been included in JDK 9. So you can see there's a lot of changes there. And this affects all different aspects of the Java platform. So we've got changes in terms of the Java language, we've got changes in terms of Java libraries, and we've even got changes in terms of the JVM itself. So what we're going to talk about is how these things affect you when you're moving your applications to run on JDK 9. The first thing to do is to look at what guidance Oracle are giving in terms of migration for applications. And I took this quote from a presentation that was given by one of the product managers from Oracle for Java SE. And they said that clean applications that just depend on Java SE should just work. And this is very precise language. And so they're kind of making sure that they set expectations about what will and what won't need changing when you move your applications to JDK 9. So clean applications, dependency on Java SE, should just work. They don't say will work, but it should just work. So what does that really mean in practice? Let's talk about the details then. Okay, so what I'm going to do now is I'm going to have a quick poll, because I'd like to understand a bit about the audience in terms of what you're doing in terms of moving your applications to JDK 9. Clearly you're listening to this webinar, so you have an interest in that. So my question is, what are your plans for moving to JDK 9? And I've given 5 answers here. One is, we've already done all the work, we have our application moved to JDK 9, so we're already using it. Second one is, you're actively working on migrating your applications to JDK 9. Third option is, we're thinking about it, haven't really started, but we're thinking about moving to JDK 9, what the issues are. Fourth option, well, okay, JDK 9 is nice, but we're not going to move to JDK 9 because of the changes to the support structure in Java SE and JDK. We're going to wait for the next long-term support release, which is going to be JDK 18.9 in September of next year. And the last option is, well, JDK 9, we're still using JDK 6. So I'll just give people a few more seconds to answer that. And I think we'll probably, at this point, we'll close the poll. Okay, thank you. And if I can see the results, there we go. Okay, so it looks like nobody has moved to JDK 9 yet. It's very understandable. 3% actively working on it. Most people are thinking about it. Looks like this is the key thing. And I guess that very much fits in with the typical audience that I would expect for this presentation. And then a few people are going to wait for the next one, and a few people are still using JDK 6. Okay, so now we'll continue with the presentation. Okay. The big thing in JDK 9 in terms of features is obviously the module system, Java Platform Module System Project Jigsaw. And this does have a number of areas where it's going to impact moving applications to the new version. So let's look at what the Java Platform Module System really means in terms of you as a developer and your applications. So the first biggest thing is that the core Java libraries, what we've become familiar with in terms of java.util, java.lang, java.net, all of those libraries, which used to be one big jar file, rt.jar, are now in a set of modules. And if you look in the JDK 9 directory system, you'll find that there are actually 97 modules for the JDK. 28 of those are for the Java SE standard. So those are the standard specified APIs that become as part of the JSR through the JCP. And then you'll find there's a set of other ones. There's a couple of JavaFX ones, there's a couple of Oracle-specific ones, but there are 97 in total. So clearly it's been divided up into much finer-grained areas, which is a really good thing from the point of view of being able to build a runtime for your application which only contains the modules that you need. So the key thing here is that there is no more rt.jar file, there is no more tools.jar file, and that could be an impact, but we'll talk a little bit more about that later on. So one thing is breaking up the standard libraries into modules. Probably the most important thing, though, from a compatibility point of view, is that in addition to the sort of 4,500-ish classes which were in the rt.jar file, which were public APIs, there were a lot of other classes which were there to support the public ones. So they were APIs which were used to actually make the public APIs work, but they weren't intended to be used by developers. Now, the most famous of those is, the most infamous of those is sunMISC unsafe. Lots of people have used that in various ways, even though it's a non-public API. And the important thing about that is that the intention from the developers of Java was to encapsulate all of those internal APIs in JDK 9. So none of them would be available in JDK 9. Now, because of the ideas of backwards compatibility, they've had to sort of step back a little bit from making them all fully encapsulated. But there are some issues that we need to talk about, which is what the following slides will deal with. So there are lots of libraries out there, lots of frameworks which have used internal APIs in the past, and they are having to migrate to using public APIs and moving away from using those internal APIs in order to work with JDK 9. The second thing in terms of changes is that in addition to the class path that we're familiar with in terms of locating the jar files and the class files that we need for our application, there's now a module path. So the module path allows the JVM or the compiler to identify where the modules are that it's going to use to compile and run your application. Now, in terms of applications, the easiest way to migrate your application is to, in effect, ignore the module system. Think of your application as a set of jar files, everything's been running on the class path, it's all been working quite happily. What you can do is you can leave that exactly the same. So leave all your classes, all your jar files on the class path, and then run them directly using JDK 9, because the class path is still there, there's no problem with using that. Now, the way that the module system integrates with that is that anything which is on the class path becomes part of what is called the unnamed module. So there's effectively one big module, which is the unnamed module, and that's everything which is on the class path. In terms of how that interacts with the other modules of the platform, or modules which are on the module path, because you can have things on the class path and on the module path, all of the packages which you have in your jar files and classes are exported if they're in the unnamed module. So anything in the class path will export all of the packages to the modules in the system. And from a dependency point of view, the runtime system and the compiler will assume that the unnamed module depends on all other modules on the module path. So you don't have a way of specifying specific dependencies between those things. It is automatically provided for you so that you don't need to worry about having to configure that. It will happen automatically through the runtime system and the compiler. What you can then do is you can take the existing jar files that you have and gradually migrate those to using the module path rather than the class path. Because ultimately what you want to do is move to where you have nothing on the class path and everything is on the module path. Now you can do that in one of two ways. You can take your jar file, you can construct a module info.java file, compile that, include it in the jar file, and then create a proper module, a named module. But you can also have what are called automatic modules. And that's where you take your existing jar file, you don't bother recompiling it, you don't bother making any changes to it, you simply move it from the class path to the module path. Once a jar file goes onto the module path, if it doesn't have a module info.class file in it, it will assume, the runtime will assume that it is an automatic module, and it will be named based on the name of the jar file that is being provided. Again, the way that works from a dependency point of view is that all packages are exported and the dependencies are resolved in terms of all modules being available to it from a dependency point of view. So you can gradually migrate things in terms of modules. Firstly, by just taking your jar files and moving the module path, and then as you have more time and you want to do it, you can actually modify it and include the module info.class file. Right, so yes. Now, one of the things is, as I said, that the original intention was that all the internal APIs were going to be encapsulated, so you wouldn't have access to those. As I said, the Java developers stepped back from that and said, okay, for backwards compatibility, that won't work in the time frame of moving people to JDK 9. So they introduced what is affectionately referred to as the big kill switch, which I think is a great name for an option on the command line. What this allows you to do is to turn off encapsulation so that you can still use internal APIs, and that way your code that has been using those internal APIs can still run on JDK 9, even though it shouldn't have access to these APIs. Now, the format of this command line flag is -- illegal access. And then there are 4 options that can be specified with that. The default is permit. Now, what that will do is when you run your application, if you use internal APIs, which theoretically are going to be encapsulated, then you will get a warning the first time you use an encapsulated API, but you won't get subsequent warnings. So you only get 1 warning for each API that you use. Second option is warn, and in that case, you will get a warning for every time you use a particular encapsulated API. So it generates more output for you. Third one is debug, and again, that will give you a warning every time you use an encapsulated API, but it will also give you a stack trace, so you can see exactly where you were using that, so how your code got to the point where it was using an internal API. And that's obviously very helpful if you're trying to track down uses of that, and you can do that that way. And then the fourth option, which is what they had intended to be the default, but obviously is not, is deny. And that's where you can turn off encapsulation, you can turn on encapsulation, sorry, turn on encapsulation, and therefore it would run as if none of the internal APIs were available. So if your code is actually completely not using internal APIs, then you could use that if you wanted to. Now, there are other ways of breaking encapsulation. So if you don't want to use the big kill switch where you turn it off completely, what you can do is you can selectively turn on availability of certain APIs. There are 2 options that you can specify on the command line for the JVM for this. So the first is -- add exports. And the idea here is that if you are importing a particular API from the internal APIs of the runtime system, then you can say, I want this particular API to be available to me. And you can do that in one of 2 ways. As the examples show here, we can say, in the case of java.management, which is the module, the com.sun.jmx.remote internal class, I want to make available to my test class. So it's only my test that will be able to use that. Or we could say in the Java management module, we have the sun.management package. And in that case, what we want to do is we want to make that available to all the classes which are in the unnamed module, which means everything on the class path will have access to the sun management package. So that's the way that we can import certain APIs. But there's another way that people use to access APIs, and that's through reflection. So there's a second option that we can use to allow reflective access to the APIs. And in that case, what we do is we use -- add opens. And as in this example here, we particularly want to say that there are some internal java.base, java.util APIs that we want, and we want to make those available to all of the unnamed packages, which means everything on the class path again. So these are the ways that we can actually get around encapsulation in the JDK 9. And then there's another thing that you can do, which is where you can, rather than specifying on the command line how to do this, you can, in your jar file, if you want to modify the manifest of the jar file, you can actually say, okay, I want to add exports for this particular this particular jar file to have access to the java.base module sun.security.provider package. And again, you don't then need to provide the information on the command line. You can just do it through the manifest. In terms of finding where you've used encapsulated APIs, clearly you can run your program and you can see where it fails or where you get warnings using the different command line options for the illegal access. But you can also run a command called JDEPS, and JDEPS will analyze dependencies of your particular package on APIs. And there's a couple of different command line options you can use with this. So just as an example, I took one of the Minecraft jar files and I ran JDEPS on that. So I did JDEPS and then I listed the dependencies that the 1.8 version of Minecraft jar file has. And we see we've got Java.base, which we would expect because everything has to have a dependency on Java.base. It's got Java.data transfer, it's got Java.desktop because it's a graphical API or a graphical application, so it needs that. Java.management and Java.naming. And then it's got this bit where it says not found. And I think that's I probably need to file that as a bug because it means that I didn't specify everything that's needed on the class path in order for JDEPS to be able to resolve all of the packages that were being used by that jar file. But I think that particular message is not very, I mean, yeah, it says not found, but it's not very clear in terms of what wasn't found. And then it says that the unnamed module is 1.8.jar. Right, now, missing modules. Okay, so if we go back to what we saw earlier, the advice from Oracle was that clean applications only use Java SE. I said that was very precise language. And what you find is that there's the part of JDK 9, which I don't really think has been terribly well publicized, but has quite a big impact in terms of certain applications. And what this means is that if you look at the modules that have been defined for JDK 9, one of them is called java.se.ee. And this module, even though it's part of the standard, is not included by default for compilation and the runtime. What does this mean? So java.se.ee is what's called a meta module. A meta module doesn't contain any specific packages, it only contains other modules. So the modules which make up java.se.ee are, not surprisingly, the ones which are related to the enterprise side of Java. And if we look at the modules that make up se.ee, you will find that there is java.corba, transaction, activation, and then some XML related ones. So there's xml.bind, and then web services annotations. So there are 6 modules which contain public APIs, but are not included by default. That means if you compile your code and you're using Corba, for example, or some form of SOAP web services which uses the XML.ws module, then it won't compile and it won't run because those classes and the packages that you're using won't be found by default. Okay, now if we want to use those missing modules, then there are various ways that we can do that. The simplest is on the command line, we can use the --add modules flag, and we can say, okay, we are using Corba, so we want to add that particular module to the ones that are available. Or if we wanted to, we could add java.se.ee and add all of them through the meta module. Second way is by saying, okay, let's ignore those in terms of the modules that are provided with JDK and use standalone versions. And if you look at basically everything except for Corba, there are modules that are available, jar files, I should say, that are available through Maven Central, and there's also a relevant JSR defined through the JCP, which contains a reference implementation. So you can download jar files for these if you want. Then, in terms of using those jar files, either through Maven or through a reference implementation from the JSR, you can use the upgrade module path flag on the JVM and specify a path where those jar files will be found. or you can deploy them specifically through the class path. So the upgrade module path allows you to provide some extra modules that are not part of the standard modules and not on the module path, or you can do it directly through the class path. So there are ways of getting around this missing module thing, but this could have an impact if you're using any of these older packages, or I say older, but any of these EE-related packages. Right, now let's talk about some of the smaller incompatibilities between JDK 9 and earlier versions of Java. So the first of these is related to the language itself. And there was a small change that was made in JDK 9, which was part of JEP 213, which was called Milling Project Coin. And what this did was it said that a single underscore was no longer going to be valid as an identifier. And that means that if you have used a single underscore as a variable name in your code and you try to compile it with JDK 9, it won't compile. You will get this message, error, as of release 9, underscore is a keyword, and it may not be used as an identifier. The idea behind this is that in a future release of Java, probably 18.3, the single underscore will be valid as an identifier used in a Lambda expression. And that way you can, if you have a parameter in your Lambda expression which isn't used in the body of the Lambda expression, you can effectively hide it by using an underscore to represent that parameter. Now, the good news is that if you are really dedicated to the idea of using an underscore as a variable name, which really shouldn't be, then 2 or more underscores can still be used. I checked this, and code will compile quite happily under JDK 9 if you use 2 or more underscores. Next thing, some of the APIs. There are a few things which may catch you out if you've used very specific things from an API perspective. So this is changes between JDK 8 and JDK 9. First of these is that the thread.stop method, which is deprecated, the version of that which takes a throwable parameter will now throw an exception. So it's going to throw an unsupported operation exception, which it didn't do before. So that means that if you had code which used that, you will now get an exception thrown, so your code will not do what it did before. If you're using the no argument version of this method, thread.stop on its own, then that won't throw an exception. So it's only the one which takes a throwable as a parameter, which will throw unsupported operation exception in JDK 9. Some deprecated methods have actually been deleted in JDK 9. Now this is a change because even though we've had deprecation right from JDK 1.1 and literally hundreds of elements in the API have been deprecated, up until now, none of them have been actually removed. In JDK 9, 6 methods have been removed. Now you might think to yourself, well, 6 methods, what have these methods done that is so bad that means that they are the ones that get picked on for being removed? And the reason for that is that when the Java developers wanted to actually create the module system and divide up the libraries into this 97 different modules, they found that there were a lot of interdependencies between different pieces of code, which made it very difficult to make a clean distinction between modules. And they ended up with a lot of situations where you got very odd combinations of modules that depended on each other. And so this is really about making the clean breaks between the modules. So the 3 classes which are affected are all in java.util. There's 2 in the jar package. There's pack200 and unpack200 class, and then there's 1 in the logging package for log manager. And of those 3 classes, there are 2 methods in each: add and remove property change listener, which have been deprecated in earlier versions and have now actually been removed. So if you use either pack200, unpack200, or log manager, add or remove property change listener, then again, your code will not work when you move it to JDK 9 without changes. There is also a deleted deprecated class. So this is an entire class which has been removed. And this is part of the Java authentication and authorization service. So back in JDK 7, this particular class was deprecated. and it's com.sun.security.auth.callback.dialog callback handler. So it's probably unlikely that most people have used this, but if you have, then again, this has been deleted from JDK 9, so you may, or you would have to make some changes in order for your code to run on JDK 9. Again, the developers of Java have provided a tool to help you understand where you've used deprecated APIs. So in addition to the ones that have actually been removed, it's a good idea to use this tool to understand which elements of the API have been deprecated and where you're using deprecated APIs. With the move to a faster release cadence for JDK, if you are going to be keeping up with the JDK itself, you may find that there are changes where other elements are being removed. So it's a good idea to analyze your code to find out what has been deprecated. New tool in JDK 9 is called JDepreScan. What it will do is it will statically analyze your class files, your jar files, against the standard Java SE APIs, and it will look for where you've used deprecated APIs, and it will report on that. So just a very simple example, here, analyzing a piece of code called deprecations, and what you'll see is that there's a type that's been used which is deprecated, RMI security manager, and then there are 3 methods which have been deprecated and that are being used. So it shows you what's actually being used, and then you can go and look at your code and figure out how to change it to avoid using deprecated APIs. As I'm sure everybody knows, if you're using a standard IDE like NetBeans, Eclipse, or IntelliJ, the IDE will already be flagging these for you as you're looking at code. So it's fairly easy to figure out which deprecated APIs you're using. The file structure of the JDK and the JRE has changed. And again, if you are actually depending on this for something in your application code, then this means that it's a change which will break your application moving to JDK 9. If we look at earlier versions of JDK, so JDK 8 and 7 and 6 and so on, what you'll find is that there is a directory structure for the JDK. Within that, you'll find a bin directory which contains the Java executable for the JVM. There's also Java C, Java H, and some other things. There is a lib directory which contains the tools.jar file. And then there's a JRE subdirectory. That has a file structure below it which contains a bin directory which contains a copy of the Java executable. You actually get 2 Javas for the price of 1 in pre-JDK 9 JRE JDK. There's also a lib directory which contains rt.jar. So this has been a bit of a fiddly structure, and in JDK 9 it's changed. So now in JDK 9, flat structure for the file system, there is 1 bin directory which contains 1 copy of Java, Java C, Java H, and so on. There is now a conf directory which contains any files which you may need to configure specifically for your version of the JDK. That's things like there's a sound configuration file in there and stuff like that. There's also the lib directory, which only contains now the native files, native libraries that are required by the JDK, because the tools.jar and the rt.java file, which, as I say, have gone away, are now replaced by the modules, and there's a separate directory for that called jmods. So if you're using the modules, that's where you're going to be finding them. So as I said, this will potentially break applications if you're relying on specific files being in specific places. But I doubt there's many people who are doing that for user-level applications. Another thing which could potentially catch you out is the new version string format. And this is JEP 223. If you look at the way that Java versioning worked in the past, it was really quite confusing, because there were these critical patch updates, there was limited update releases, and even the version number. If you go to the Oracle website and you download Java SE version 8 update 131, and then you run Java -version on that, what it will report is JDK 1.8.0_131. So this goes way back to JDK 1.2, when it became Java 2 SE version 1.2, and then we had version 1.3 and so on. So engineering kept the 1 dot even though it was called Java SE8. So it became very confusing. Also got confusing in terms of how many patches were in different updates. So you would think logically that update 60 would have more patches than update 55, but the reality is it's the other way around. So now we have a new versioning format, which is only going to be valid for this version, because when we move to the next version, the proposal is it will be 18.3, 18.9, so it'll have to be modified again. But for now, JDK 9 uses major, minor, and security separated by dots. Much more easy to understand by humans, much more easy to have like a semantic versioning kind of thing. So as I say, potentially if you were relying on using the version string of the JDK for something, that could break your application as well. A couple of things about non-programmatic issues. If you're using the Java Network Launch Protocol for web start type things, the way that the configuration files for JNLP are parsed has changed. So there's now strict parsing of the configuration files, which means you have to have closing tags as well as opening tags in some of the XML that's being used. What that means is, again, from a backwards compatibility perspective, some of the files which you had which would have passed in the past because they weren't using strict parsing will now fail. So that might be something you need to be aware of. Because of the changes in terms of modularity, the class loaders that are used by the JVM have changed. There are still 3, but things like the boot class path has gone away. And what this means is that the extension mechanism and the endorsed standards override mechanism have also gone away. They've been removed from JDK. What the impact of this, which may catch a couple of people out, is that there's a couple of directories which have been removed. So if you look in Java Home in JDK 8, you'll find there's a lib directory, and then below that there's an ext directory and an endorsed directory. If you're using something like JNI, then you might put things in the ext directory. If you do that, you create an ext directory or an endorsed directory in the lib directory of the JDK, what you'll find is you get this message will come up. So it'll say lib ext exists, extension mechanism no longer supported, use minus class path instead. And the Java virtual machine will not start. So you will have to make some changes to how your files are configured and the command line you're using to start the JVM. A number of things were removed from the JDK in JDK 9. A number of command line options were removed because of garbage collection options having been deprecated in JDK 8. So if you're using any of these command line options to start your JVM, you will need to change it because these will stop working and the JVM will not start. Primarily it's around the incremental concurrent mark sweep. There's a couple of other options there, things like if you're using parallel new and the serial old combination, that won't work now with JDK 9. So these are some things to be aware of when it comes to configuring your JVM at startup time. Logging. So logging of the JVM changed in JDK 9, and the basic change was the introduction of what's called unified JVM logging. So a common logging system for all components of the JVM, which changed the format of messages, changed the way that you configure the logging to actually happen. So again, if you are doing anything which parses logging messages that you get from the JVM, so some strange thing that you're doing which involves looking at messages coming from the JVM, then you may have to make changes because the format of those messages may well have changed. Related to that is obviously the fact that GC logging is now using the unified JVM logging system, which means that you get different output for GC logs than you had before. So tools that were being used to analyze GC log files may or probably will not work with log files generated by JDK 9. It also means that a lot of the command lines options have changed, which we'll talk about in a moment. In fact, JVM Flags. I did a lot of analysis on this because it turned out that there's some quite interesting things that have happened from a JVM Flags perspective. So the easiest ones are these. So these are JVM flags which have been removed from JDK 8 and are no longer available in JDK 9. And these, obviously, some of these are related to some of the GC options, but there's also a whole range of other things there that are no longer supported in JDK 9. Now, the good thing about these is that they won't stop your JVM from starting. So if you're using adaptive size policy, size pause policy, or alternative signals, then you'll get a message which says server VM warning, ignoring option, blah, support was removed in JDK 9. So you can look at the output and you go, okay, we'll do something about that. A number of command line options which were in JDK 8 have been replaced in JDK 9. So these are deprecated JVM flags which have been replaced. So again, what I've done here is I've listed out all of the ones which had a JDK 8 option, which has now changed in JDK 9. So things like print GC, that's a very common one for people to use. You now have to use -xlog : GC, and if you want GC details, you do -xlog : GC star. There's a couple there I've given suggestions for because there isn't an exact replacement. And then a lot of the tracing ones. So if you want to look at class loading, redefine classes, safe point cleanup time, all of those things, because it's now using the unified logging system, you use -xlog : and then specify exactly what it is that you're looking for. And convert sleep to yield, there is no JDK 9 replacement for that particular one. So if you use those flags, you'll get one of two warning messages. You'll either get a warning message which says print GC is deprecated, we'll use xlog GC instead. So that's nice because you don't have to change anything. You just get a warning saying, yep, you're using the wrong flag, we'll change it for you automatically. Or you'll get a warning message with a little bit more detail that said, option create mini dump on crash was deprecated in version 9 and will likely be removed in a future release. Use option create core dump on crash instead. So again, your JVM will still start, it will still do the same thing that it was intended to do before. Then we have the non-starter flags. Now, I'm not going to go through all of these, but I've listed them out so that when you get the slide deck afterwards, you can actually look at this in more detail. I've also written a blog entry on this where you can get more detail about this as well. So, as I said, the removal of the GC combinations that were deprecated in JDK 8, obviously you can see there's a lot of things around concurrent mark sweep, incremental mode, and how those have all been removed. But there's also a lot of flags related to printing information. And so, like GC application concurrent time, GC application stop time, and so on. GC date stamps, probably something that some people have used. So that's one page full of non-starting flags. And then there's another whole page of non-starting JVM flags. So most of these are printing out things, tracing things. So if you're looking at like the TLAB information, the thread local allocation block stuff, then heap at GC, heap at GC extended, if you're trying to do detailed analysis of GC type problems, then these things might catch you out. So there's quite a lot of these options. And what's going to happen in this case, there are 50 command line flags from JDK which are not supported in JDK 9. If you use them on JDK 9, it will actually abort the JVM at start. So your application won't run. And this is, like I say, this is quite a significant thing because it's not like it's saying, oh, just give a warning and let your application run. So you'll get this warning message, or this error message. It'll say unrecognized VM option, could not create a Java virtual machine, fatal exception has occurred, program will exit. Okay, so let's look at a real world example of moving a piece of code from JDK, well, let's say JDK earlier to JDK 9. And this is a piece of code that was written by our CTO, our real CTO, as opposed to the deputy CTO that I am. Gil Tene created the HdrHistogram Library. It's an open source library that's used for analyzing things like latency, pause times that you get in terms of the JVM. Now, what you really want, because this is library code, is that this library should work with JDK6, JDK7, JDK8, and JDK9 without any problem. So what you want is one jar file which contains all of the code for your library, and you want it to run on all 4 of those JDKs without any command line flags, without having to do anything special. So how do we go about doing that? Well, the problem that this particular library has is that it needs to encode and decode data using base64. So base64 encoding and decoding. How do we do that? Well, there are actually 3 ways that you can do it depending on which version of the JDK you're using. So if you look at JDK 6, 7, and 8, there is an internal API, an unpublished, undocumented API, which is Sun, MISC, base64, encoder, and decoder. And this is, these are the first and third most popular internal APIs that Oracle's analysis found people had used in terms of the internal APIs. Sun, MISC, Unsafe was number 2. So there are these internal APIs that can be used. There's also a public API, which is part of the javax.xml.bind package. And in the data type converter class, there is a way of doing encoding and decoding of strings of text. That will work on JDK6, JDK7, and JDK8. Problem is it won't work on JDK9 because, in theory, you've got encapsulation of the private APIs, and you would need a special command line option to enable your code to use that. The data type converter won't work on JDK9 because it's part of the java.ws.bind package, which is javax.xml.bind, which is part of the java.ws module, which, if we remember back to java.se.ee, not being included by default. So base64 encoding and decoding is not possible through those APIs in JDK9. In JDK8, a public API was introduced. So you've got java.util.base64 encoder and decoder classes, which are available in JDK8 and JDK9. Unfortunately, none of those solutions matches all 4 of the JDKs that we want to support. So how do we get around that? Well, the answer is we can do that with a little bit of, well, a helper class. So create a helper class which has the same named methods as the XML bind package ones. Obviously, if you've got code like this, you might need to do it in a slightly different way, but because the XML.bind classes had already been used, it was easier just to make the helper methods the same so that it involved less changes. So yeah, print base64 binary, parse base64 binary. One takes an array of bytes as input, one takes a string as input. What you then do is create a static piece of code to determine which class is available, and then initialize a method object reference based on which class is available, so that the helper methods can invoke through the method reference. So this is in effect using reflection through the method reference to use the implementation which is available for whichever JDK your code is running on. So that way you can take the same library jar file, you can use it on JDK 6, 7, 8, or 9, and you don't have to specify any special command line flags, it will just run. So just to look at the code for this, essentially all of this code would go in a static block. And what we do is we say, okay, let's try and load the class java.util.base64, which is the public one, which would be available on 8 and 9. Now, if that fails, because that class isn't there, so if we're running on Java C7, then we'll throw a class not found exception, which will drop through the catch block down here, and we'll set both the decode method and the encode method to be null. If we can load base64, then we need to get a method reference to the decoder through the get decoder method of the base64 class, and that will return us the base64 decoder class because it's an inner class, and then we need to get the method on that to do the decoding. Same thing for the encoding. So we have to go through an inner class in order to get the class which we can then reference the method of. So it makes it a little bit more complicated. But ideally, we will then, so long as java.util.base64 is there, we will have 2 methods. By catching the throwable, we catch the class not found exception, but also if for some reason the method is not there, then we can trap the no such method exception as well. And then if that fails, so if we say if the encoder method is null, so we didn't have java.util.base64 available, then we assume that we're running on an older version of the JDK, and so in this case we'll load the javax.xml.bind.datatype converter, which is available publicly in earlier versions of the JDK, and then we can get the decode method and the encode method directly from that because they are part of the data type converter. And then again, we'll catch a throwable, but if we catch a throwable at that point, we have nothing that we can do. So this allows us to select which is the appropriate version of the methods that we want to use based on which version of the JDK without needing to know that explicitly. So we just try to load things and then catch the exception. Okay, so to kind of conclude then, let's just sort of talk about this. So migrating application to JDK 9. Simple applications will run almost unchanged. If you've got things like some odd command line arguments, then you may have to make some changes. Leaving everything on the class path, as long as you don't step outside of the public APIs, then you shouldn't have any problems. JVM flags may be a bit of a thing. If you're using encapsulated APIs, then you may have to add additional command line arguments, or you have to do things like we just saw in the code for dealing with base64 encoding and decoding. So it can be quite tricky to deal with that. As you migrate your applications, using things like JDEPs is a very good idea because it allows you to analyze your code and figure out where there are things that need to be changed, and then you can identify those and then rectify the issues. There are a few small things which may cause you problems, so things like the removed APIs, the removed class. If you're using some of the like JNLP and you've got non-strict configuration files, then there's little things like that might catch you out. And as I said, there's a whole range of command line flags which have changed between JDK 8 and JDK 9. So that's, yeah, a couple of useful links. So Oracle have created a nice migration guide. So there's docs.oracle.com/java-se/9/migrate. And then I have written a couple of blog entries, one which I call Pitfalls for the Unwary, which is really sort of what this presentation is based on. And then there's also, I think, about new command line options that are available in JDK 9. So this is all about changes between JDK 8 and JDK 9. And then the last thing I want to just briefly mention is the fact that as Azul, what we do is we have a binary distribution of the OpenJDK. So this is free as an alternative to ones you can get from other people. We build this from OpenJDK, so it is a standard build of OpenJDK, passes all the TCK tests because we run the TCK on it after we've built it. It is multi-platform, Windows, Linux, and Mac. It is free. We're quite happy to sell you support. So if you're using older versions of the JDK and you want support, then we're happy to talk to you about that. We support JDK 6, 7, 8, and 9. And so what we actually do is we backport things like security fixes from JDK 8 into JDK 7 and JDK 6. And if you want, you can get the download from zulu.org.